Hello, fifth grade. This is our science time. It is Thursday, the 30th of April, 2020. We are on page 196. We're going to be talking about Into the Wild Blue Yonder, the spheres above the sphere that we live, S-P-H-E-R-E. We're going to talk about the troposphere, the stratosphere, the mesosphere, and the thermosphere and exosphere, okay? So I want to look at our comp check really quickly so we see what we're highlighting today. It says, number one, name the atmosphere layer where you would find the following. What layer, what atmosphere would you find air glow, B, meteors, C, the ozone, D, weather? What spheres will you find those in? Number two, give the word that best fits each clue. A shooting star. What's a shooting star? B, a light caused by Earth's magnetic field and solar wind. C, atoms with lost electrons. D, an oxygen molecule with 3 atoms instead of 2. E, made of subatomic particles from the sun. F, a faint light caused by ions. And number 3, what does the ozone layer protect us from? We talked a little about that yesterday, about the importance of the ozone layer. Okay, so let's start reading. So those are our highlighted questions for today. I'm writing something down real quick here. It says, the troposphere. Of all the layers of the atmosphere, the troposphere lies closest to the Earth. It is the narrowest band in the Earth's protective wrapping. The troposphere extends upward for about 6 miles above the poles, north and south poles, and about 12 miles above the equator. That much distance may sound like a long way to you, but it is really only a small fraction of the total height of the atmosphere. If you were to make a model in which the height of the atmosphere was scaled down to 1 yard in length, the section of the model representing the troposphere would measure less than ½ an inch. But despite the narrowness of the troposphere, the force of gravity has managed to pull and compact most of the atmosphere's air into this region. It is no accident that in the troposphere, the air is much thicker than in the upper layers of the atmosphere. People and animals need the greater density, the greater thickness of air in order to breathe. So if you look at on page 197, you see the troposphere. That's where life happens, okay? And even though it's just a small band compared to some of the other spheres, look at the difference between some of the other spheres. It is the most densely, has the most dense pack, I guess you could say, worded of air and everything that we need in order to live. We talked about air, water, everything necessary yesterday. So through the process of evaporation, molecules of water in oceans, lakes, and rivers are made to vibrate so violently by the warming power of the sun that some break free from the rest and turn into water vapor. Okay? So I'm going to read that again. Through the process of evaporation, we know what evaporation is, molecules of water in oceans, lakes, and rivers are made to vibrate so violently by the warming power of the sun that some break free from the rest and turn into water vapor. The water vapor mixes with the air molecules of the troposphere. Because it holds almost all of the water vapor in the atmosphere, the troposphere is the exclusive home of weather. Okay, this troposphere is the exclusive home of weather. So when we're looking at number 1, it says name the atmosphere layer where you would find the following. I see that D says weather. So I would write D dash weather dash troposphere. Okay, that's where we find the weather. Only in the troposphere do raindrops drizzle, lightning bolts flicker, and hurricanes howl. Okay, and that's the sphere where humans live. Life happens. The stratosphere. So look at the stratosphere. That's your next sphere. Okay, have some jet fighters in there, some air balloons in there. Above the troposphere is a layer of the atmosphere called the stratosphere. Because there is almost no water vapor in the stratosphere, clouds do not form in this region. Aircraft often fly through the lower portion of this layer in order to escape the turbulence of weather. The temperature in the upper parts of the stratosphere can reach 37 degrees Fahrenheit, as ultraviolet rays from the sun warm the air. The lower part of the stratosphere can be a frigid negative 87 degrees Fahrenheit. Okay? Aircraft, it says, only fly through the lower portion of this layer, like we can see here, the lower portion, all right? Because it says, I wanted to read that part again, they only will fly above to escape the turbulence of weather that you find in the troposphere. So if they have to, go up higher, I can't think of the word, it's not accelerate, I can't think of the word right now. But if they have to travel higher in altitude, it's because they're trying to get out of that troposphere if there's really rough weather, okay? So that makes sense. It says the temperature in the upper parts of the stratosphere can be 37 degrees, but the lower parts are negative 87 degrees. If you have ever had a painful sunburn, I have, you know that too much exposure to the sun's rays can be harmful. As you remember, sunburn is caused by ultraviolet radiation, invisible light beyond the violet end of the spectrum. Ultraviolet rays can also cause a serious condition called skin cancer. To protect the Earth from ultraviolet rays, God has placed in the stratosphere an invisible shield of gas called the ozone layer. Ozone is a form of oxygen with 3 atoms of oxygen in its molecule. The oxygen we breathe has only 2 atoms in its molecule. Ozone is formed when ultraviolet rays strike and split an oxygen molecule. When a free atom combines with another oxygen molecule, a molecule of ozone is formed. Ozone then soaks up most of the ultraviolet rays to protect us coming into the atmosphere. Okay, so I'm going to read that part again. Ozone is a form of oxygen with 3 atoms of oxygen in its molecule. The oxygen we breathe has only 2 atoms in its molecule. Ozone is formed when ultraviolet rays strike and split an oxygen molecule. When a free atom combines with another oxygen molecule, a molecule that's split is a free atom, a molecule of a molecule, when a free atom combines with another oxygen molecule, a molecule of ozone is formed. Ozone then soaks up most of the harmful ultraviolet rays coming to the atmosphere. So you can see in this picture, we see in the stratosphere, we see the ozone layer. Okay, the ozone layer, which God created. Remember, everything God created was for a purpose, to protect us from the rays of the sun. Okay? The mesosphere. Above the stratosphere, a very cold layer of air called the mesosphere helps to protect the Earth from being constantly bombarded by objects from outer space. Every day, millions of pieces of space debris called meteoroids hurtle into our atmosphere. Only a few strike the Earth, however, because friction in the mesosphere causes all the rest to burn up. Remember that friction is a force that resists the movement of an object over some other object or through a fluid such as air or water. As each meteoroid enters the mesosphere, it hits a sea of air molecules. The collision between the meteoroid and the air molecules causes friction. It stops them, okay? Causing the meteoroid to become very hot and to burn. Burning meteoroids are called meteors or shooting stars. If that didn't happen, they would shoot, right towards Earth in greater force and stuff. So here's an example of friction. When you're swinging on a swing, when you put your feet down on the ground, it's going to slow down so you can get off the swing. Okay? That's friction, your feet coming across. So you put your feet down. It doesn't stop usually instantly. That would hurt. but it slows down. So then the swing, so you're swinging really high, you put your feet down, it slows down a little more, it slows down a little more, it slows down a little more until you stop, okay? So we see friction here in the, we're talking about the mesosphere. We see that friction is what slows down those meteoroids so they do not come crashing all day, every day down to Earth with great force. So I wanted to show you so you can see that picture of the mesosphere, and you can see the meteors coming, okay? And so everything God does is for a purpose. So there was another in section 1 on your comp check, which says name the atmosphere. It says where meteors, come, and we just read that's the mesosphere. For C, it says the ozone, and we just learned that the ozone comes from the stratosphere, okay? We're still looking for air glow, all right? So let's look at the thermosphere and the exosphere. I'm on page 198, right here, right here. The two layers above the mesosphere are called the thermosphere and the exosphere. The air in these regions is said to be rarefied or scarce. Can't breathe up there because there are very few air molecules. The farther one goes, the more rarefied the air becomes, the less air there is. If you see a strange light in the horizon on a moonless night, you may be witnessing a phenomenon called air glow. Okay, so we see that air glow takes place in the, which question was it? In the thermosphere with letter A. The air in these regions, I already read that. If you see a strange light in the horizon on a moonless night, you may be witnessing a phenomenon called air glow. Air glow occurs in the lower region of the thermosphere. In order to understand what causes air glow, you need to remember that matter is made of atoms. An atom, in turn, is made of tiny parts called subatomic particles. Electrons, one type of subatomic particle, whirl around the center of each atom. As solar rays enter the thermosphere, they strip electrons from their atoms to create ions. Ions, the atoms with the lost electrons, cast the light we call air glow. So there's a lot spinning, twirling, a lot going on to cause air glow. Because ions cause air glow, the lower region of the thermosphere is often called the ionosphere. Okay, so I want to read that again. In order to understand what causes air glow, you need to remember that matter is made of atoms. We know that, matter. We know what matter is. An atom, in turn, is made of tiny parts called subatomic particles. Okay, tiny parts. Electrons, one type of subatomic particle, whirl around the center of each atom. They're whirling around the center of each atom. As solar rays enter the thermosphere, they strip electrons from their atoms to create ions. These ions, the atoms with the lost electrons, cast the light we call air glow. Okay? Because ions cause air glow, the lower region of the thermosphere is often called the ionosphere because there's a lot of air glow that you can see. So you can see air glow here, the air glow region way up here. Okay, up here in the thermosphere. All right. If you live in the city, you will not be able to see air glow. Too many lights, right? City lights shine too brightly for you to see the faint light of the ionosphere. However, you may be able to hear the result of an activity taking place in the ionosphere if you listen to shortwave radio. The ionosphere not only shines a strange light in the sky, but it also has an important effect on radio broadcasts. Some radio waves can be bounced off the ionosphere, making it possible for broadcasts to be sent long distances around the Earth. As you move away from the Earth into the upper region of the thermosphere and even farther into the exosphere, oh, wrong page, sorry. The exosphere, okay, The air becomes so scarce that it is thought an atom can travel for 6 miles before bumping into another atom. Although the exosphere is the topmost layer of the atmosphere, it is not the end of the Earth's protective wrapper. There is yet another covering designed by God to safeguard the world. So just think about that for a minute. All of this that we've been talking about today, the spheres, the tropho and the stratosphere and the mesosphere and the thermosphere and the exosphere, this is just what God wraps Earth up in. All of this is how careful he is to cradle. If earth was in my hand, where his creation, his beloved people live, the loves of his heart, he protects that earth, okay, with all of this. And then he says, we're reading in science just now, that there's even more that he wraps us and protects us in to take care of us. That will stay constant. All right? Something God makes doesn't break. Okay? So beyond that is something called the magnetic field. In chapter 6, you studied about magnetism. You also learned at the beginning of this chapter that the sun has a magnetic field that shows itself in the form of sunspots. The earth has a magnetic field with a north magnetic pole located near the geographic North Pole and the south magnetic pole located near the geographic South Pole. The whole earth is surrounded by this magnetic field, which protects the earth from harmful space particles. So then on top of all of those spheres, he's got a magnetic field. Outer space is not empty as people once believed. Rather, a solar wind made of subatomic particles from the sun speeds through space at 1 million miles an hour. The Earth's magnetic field, like a giant suit of armor, defends the Earth against these particles, which would be very harmful to living things. Think about that. What did it say? 1 million miles an hour coming at us. God protects from all of that, is what we're talking about. When particles from the solar wind reach the Earth's magnetic field, some of them are guided on a path through the Earth toward the North or the South Pole. At the poles, the particles collide with molecules of air in the thermosphere. The many collisions create a light display called an aurora. These spectacular displays of light can be seen at night from regions close to the North and South Poles on the Earth. Auroras appear as shimmering bands or curtains of color, as shooting rays, or as a steady glow, and they can be seen in any color of the spectrum. The northern lights are called the aurora borealis, and the southern lights are called the aurora australis. These lights are brilliant reminders of God's protective magnetic field. So you can see the aurora borealis there in the northern lights. And you can see also here the auroras, these beautiful lights, okay? As you gaze up into a clear blue sky, you do not see the many layers that are part of the Earth's atmosphere. All we see is what's, we might see a plane fly by, we can see the moon, we can see the sun. We don't see all this beautiful, incredible, powerful blanket that God holds us in. But we know it's there. All you see is blue. But when you catch a glimpse of a falling star, or view the airglow on a moonless night, or witness the splendor of an aurora, remember that the atmosphere is God's protective wrapping around his most precious creation, the earth. And why is the earth precious? Because of you. Because he loves you so much. Because of mankind, because of his creation, the loves of his heart. He protects us and holds us in this incredible wrapper that nothing or no one can penetrate. No one is more powerful than God. And so just think about that the next time you're looking up in the sky, about how the different spheres and how much extra care. I mean, he left no stone unturned to protect us. What a God, what a Savior, what a Creator.